Good day, maayong adlaw to our senior high school STEM students. In this video lecture, we will be discussing the third chapter of our pre-calculus class, in which the contents are the series, sequence, and sigma notation. You might have probably heard those lessons before in your grade 10, but this time we are trying to delve into more examples and more complex lessons, but we are going to do it step by step. Okay, so let us start this video discussion. Let us start this discussion by simply appreciating the beauty of these objects. Try to look at the flowers. There are many seeds. Can you count these seeds? As you can see, they are arranged accordingly in patterns. The same also with the patterns that you can see of the progression or the increase of heights of the plants, okay, with an interval each day or each time, each minute. Okay, the same also with the created seeds, the series of seeds, many seeds in a coliseum or in an arena. Can you count all of them? Probably not. You cannot. Also with this firm in which it looks like a Fibonacci sequence, you see the world is composed of many objects which are really subject to mathematics. Mathematics is everywhere. You can solve all these problems counting these so many things with the help of our lesson today. Just the basics of the series and the sequence. We start with the arithmetic sequence and series. As you may all know, sometimes there are so many objects in a set and you cannot count them all. But with the help of these formulas, equations later on, we can solve it. Let us try to exercise our brain with this thing here. You can see these sets. You have 1, 4, 7, 10, 13. And what do you think is the next term of this? What do you think? The next term is 16. The next term is 16. It is called arithmetic sequence because and see the pattern pretty obvious. 1 plus 3, that is 4. 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. 13 plus 3, that is 16. So you can just look at it and you can sense what is the next. So what was your technique in doing so? Maybe you subtracted 4 to 1. 4 minus 1, that is 3. 7 minus 4, that is still 3. 10 minus 7, that is still 3, and so on. So when you subtract it here, of course, on the other side you're going to add. So 13 plus 3, that is 16. So that is what we call the arithmetic sequences. We're just going to add the common difference, which is 3. Again, the common difference is you're going to subtract 4 minus 1, that is 3. 7 minus 4, that is 3. So they're common 3 in each interval. So you're going to add so that you can get the next term. How about if this is the situation here? It becomes 2, 4, 8, 16, 32. In this case, this is very easy. You can have 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. What is the common ratio? So you call 2 as the common ratio because it keeps on repeating. Multiply it by 2 all the time. 2 times 2, 4. Times 2, 8. Times 2, 16. And so on. So later on, you will be able to find the common difference and the common ratio. Common difference is for the arithmetic sequence, and the common ratio is for the geometric sequences, multiplication. Let us appreciate it even more. 1 minus 9, that is negative 8, I guess. Okay, negative 7 minus 1, negative 8. Negative 15 minus negative 17, that is negative 8. How about here? Look at here. If it is multiplication, then the reverse of it is division. So negative 3 divided by 9, so that must be 1/3. 1 minus negative 3, that is 1/3. I mean divide, no? 1 divided by negative 3, that is 1/3, negative 1/3. Negative 1/3 divided by 1, that is still negative 1/3. So the common ratio is negative 1/3. And so on. You can observe all of these. Okay? So what is this series? Just to give you a preview. Series. What is this 35? How were we able to solve 35? We just added them all. 1 plus 4, 5 plus 7, 12 plus 10, 22 plus 13, that is 35. Same also here. 9 plus 1, 10 minus 7, negative 3 plus negative 15, negative 12. That's it. And also here, though it is a multiplication, but still we are looking for the series, that is addition. 2 plus 4, 6 plus 8, 14 plus 16, that is 30. 30 plus 32, that is 62. That is series. Now you can see the difference now. Sequence is a set. It has a comma. But in the series, you're going to add them all. Okay? Later on, you will know. Let us know some terminologies. That numbers in sequences are called terms. You can think of a sequence as a function whose domain, the domain is the x, or something that is being substituted, is a set of consecutive integers. If a domain is not specified, it is understood that the domain starts with 1. Let us have a concrete example. The domain gives the relative position of each term. You have, okay, as you can see, we have the series here, 3, 6, 9, 12, 15. The common difference of this is obviously 3, because 6, diba? The distance from 3 to 6 is 3, 6 to 9 is 3, 9 to 12 is 3. So this thing here is what we call the range. Just like in GenMath, right? Domain, x, or input. Range is the output, or y, depending on the switching. So the domain, the domain is, or the domains are the placement or the ranking asa ang the terms, no? First term, second term, it is just a ranking. First term, second term, third term, fourth term, fifth term. There are 5 terms in all. So the range is the actual. Diba? We know that the domain is something that is being substituted. And when you substitute something into an equation, it produces an output, which is the range. So that is 3. Substitute 2 to an equation, that becomes 6. So what is the certain equation, by the way? The certain equation is obviously 3 times n. Because when you substitute 1, 3 times 1, that is 3. 3 times 2, that is n, that is 6. 3 times 3, 9, and so on. So take note that the n are the terms, a sub n's are the output, or the actual terms. Therefore, a sub n represents the nth term of the sequence. So in this example, you have the equation a sub n is equal to 2n plus 3. So again, what is n? N is the domain. Okay, something you substitute in. So first 5 terms. So the first term should be 5. Why is it 5? Let me use the pen. It is 5 because you just substituted first term, the domain x, 1, 1. And here, you have 1 here. 2 times 1, that is 2, plus 3, 5. Simple. The second term is 2. Okay, 2. So if you're going to write that here, you have like 5, comma, 7, comma, what's next? Can you guess? That is 2 times 3, or 6, plus 3, 9. Okay. You have 9. Next, 4. 4 here. 4 times 2, 8 plus 3, 11. And we are down to the last one, which is 5. 2 times 5, 10 plus 3, 13. So we call this as a finite or finite, no? Finite or finite, because it ends in the fifth term. So again, this is the first term, the second term, the third term, the fourth term, and the fifth term. That's it. That is how you find the terms in a sequence. Let us have another example. This is a rational function this time. So very simple. Just substitute the first term, which is 1, in every n that you can see. You have two n's here, so you just substitute 1 over 1 plus 1. 1 plus 1, that is 2, so that's 1/2. Another 2, n, there are two n's. So 2 over 2 plus 1, the 3, and so on. I know you know how to do it already. So the terms are 1/2, 2/3, 3/4, 4/5, and 5/6. Another example. Have you seen this symbol before? Exclamation mark. This is called the factorial. Okay, let me write it in. That is factorial. What does this mean, the factorial? You may probably use this in your calculus classes. Factor. It's factorial. Example, what is the factorial of 5? Example here. Factorial of 5, or 5 factorial. So you're just going to solve it like this. Like 5 times, hold on, 5 times 4 times 3 times 2, it's okay, times 1, sorry, that is 1. Okay, so you have 5 times 4, that is 20. 20 times 3, that is 60. 60 times 2, that is 120. 120 times 1, that is 120. Therefore, the factorial of 5 is 120. That's it. These are commonly used in permutations or other things. Let me erase it up. Okay. Let us have the sequences again. Okay, so how was it done? So you have, hold on. You have 1. So 1 factorial, 1 times 1, that is still 1. So 1 minus 2, that is -1. How about 2? 2 times 1. You only have 2 times 1. That is 2. Minus 2, 0. How about 3? 3 times 2, that is 6. 6 times 1, that is 6. 6 minus 2, that is 4. How about 4 factorial? So 4 times 3, that is 12. 12 times 2, that is 24. Right? 24 times 1, that is 24. 24 minus 2, that is 22. How about 5? We already answered that earlier. That is 120 minus 2, 118. These are the terms. Let us continue. How about exponential functions? In the exponential, you have n here, right? N as an exponent. So we know it very well already. 1 minus 1, that is 0. Right? So -10, -2 raised to the power of 0. So by the way, anything that is raised to the power of 0 is always equal to 1. Example, 4 to the power of 0, that is equal to 1. That is a special property, and I'll explain to you that one on the next video or whatever. Okay. Okay, so that is 1. So -2, Okay, 2 minus 1, that is 1. Negative, okay, that negative 2 raised to the power of 1, still negative 2. Negative 2 raised to the power of 2, that is 4. To the power of 3, or cube root, or yeah, negative 2 cube, rather, negative 2 times 2, 4. 4 times 2, 8. 5 minus 1 is 4. So you multiply 2 quadruple times. Hold on. So you have 2 times 2, 4. 4 times 2, 8 times 2, 16. So you have 16. These are the 4 terms, the 5 terms. Okay, let us go directly to the next lesson, because it's going to be a long lesson. Hold on, what's happening to the mouse? Okay, so we have arithmetic sequence whose consecutive terms have a common difference. Okay, so again, how to find the common difference? You're just going to subtract 5 and to 3. So as you can see here, you have 5 minus 3 is 2, right? 7 minus 5, still 2. 9 minus 7, that is 2, and so on. As long as you can see there are 2 the same thing, or 3 if you want to check it, then that's the common difference already. Your interval, it is denoted as letter D. Okay, how about this one? Is this an arithmetic sequence? But you can consider arithmetic sequence if it has an equal common difference to all. Let's check. Negative 30 minus negative 45, that is positive 15, right? Negative 15 minus negative 30. Be careful with the integers. You might get wrong. Let us have a very quick review, diba? Negative 15 minus 30, right? This is 30. Negative 15 minus 30 minus 30. Diba, we know if it is subtraction of integers, you change the sign of the operation, you change also the sign of this. Did I got it right? Yeah, it is negative, so already negative, so it becomes positive. So that is 30 plus negative 15, that is positive 15. So again, change the sign of the subtrahend and change the operation. So that is how it goes. Okay, 15, the same also 0 minus negative 15, that is 15. That is comma, yeah, it is an arithmetic sequence. Next, oh my god, diba I mentioned to you that if, okay, if, hold on, if you have this equation like 2 4 6, you have this sequence like 2 comma 4 comma 6, there are how many terms? 3. But if you have this sign here, which is called, what do you call this one? Ellipsis. Okay, if you have this ellipsis here, just like when you type in something, it signifies continuous. Ellipsis, that means it goes to infinity. It goes to infinity. That's it. So we do not know when it will end. Okay, just like in our relationship. Okay, so you have, okay, for example, find the next 4 terms. So in finding the next 4 terms, how to do it? You're going to find, of course, the common difference. Negative 2 minus 9, let me check. Negative 2 minus negative 9. Again, do not be confused with the symbol if it is subtraction. So what to do? Change the subtrahend, plus, and change the operation. That is now positive 7. Is this correct? Positive 7, yeah. How about this? 5 minus 2, still positive 7. So you have 7 as your common difference. Okay, so we add 5 plus 7, that is 12. 12 plus 7, 19, plus 7, 26, plus 7, 33. That's it. These are the next 4 terms. Very simple. How about this one? 7 minus 0, that is 7, right? 14 minus 7, that is the common difference is 7. The D is 7. So you just add 7. 14 plus 7, 21, and so on. How about this? Negative 2x minus, can you check this out? Hold on. Negative 2x minus negative 3x. So change the subtrahend, change the operation, that is now 3 is greater than, so that must be positive x, right? 3 minus 2. So x is the common difference. So negative x plus x, that is 0, right? Is it correct? Yeah. 0 plus x is x. X plus x, 2x plus x, and so on. And this one too, negative k, let me check out. Negative k minus positive 5k. The common difference is, change, this is positive, it becomes negative, operation becomes positive, so that is negative 6k. So the common difference is negative 6k. Let me write it here. Yeah, this one. So you're like negative 7k plus negative 6k, negative 13k plus negative 6k, and so on. It goes on and on and on. How do you find any term in this sequence? Any term. Let us see. Diba? To use, can you memorize this formula? A sub n is equal to a sub 1 plus n minus 1 times d, where the d is the, we all know, the common difference. The n, what is it, the n again? The term, right? The first term, second term, third term. And the a sub 1 is the first term in the line. Kinaunhan. A sub n is the term in which you are looking for. Okay. Example, 2, 4, 6. You are looking for 6, so that must be a, no, hold on. You are full. 6 is in the third term, so that must be a sub 3, right? Again, 2, 4, 6. Let me write it in. 2, 4, 6. That is the sequence. So you have 6 is at the third term, first, second, third. N is the 3. And a sub 1 is 2. Common difference is 2. And you just have to copy that. And the answer for that is 6. Therefore the a sub 3 is 6. Later on we'll have the examples. How do you find any term in the sequence? Again, let me just, okay, just a quick break or a trivia. Okay, so you have Gauss. No, it is said that when the famous mathematician Carl Friedrich Gauss was a young boy at school, his teacher asked the class to add together every whole number from 1 to 100. Here, they are tasked to, like, 1 plus 2 plus 3 plus 4 plus 5 plus 6. Can you do that? What do you think is the answer? Up to 100. But it would take you a lot of time, so the teacher expected this activity to keep the class occupied for some time, and so he was amazed when Gauss put up his hand immediately and answered, 5050, sir. Wow. How was he able to do that? So this is how it works. Okay, you can notice, no, you can add together consecutive numbers by writing the numbers once in order. Okay, again, once in order, that is 1, 2, 3, 4, 5 up to 100, and once in reverse, bali, 100, 99, 88, 98, 97, so on. It goes like this. As you can see, you have 1, 2, 3, 4, 5 up to 100. Again, what is this? Ellipsis, that means continuous. And then the other one is reverse, 100, 99, 98. And if you're going to add it like this, 1 plus 100, 101. 2 plus 99, 101 again. 3 plus 98, 101 again. That sounds good, no? Interesting. 100, 100, 100, 100, 100, and so on. Still 100. So how many 101 here? Pila ka buok 101? Diba? There are 100 101s. Ayan. So you multiply 100 times 101. There are two sums, two s's. So that is 10,100. So you divide it by 2 to find the s. So like 10,100 divided by 2, that is 5,050. So that is the answer. So kindly take note of the formula. Yeah, like this. You divide it by 2, right? 2s divided by 2, right there. So I divided by 2 also here. We will be using these later on. Okay, so the sum of the first n natural numbers. We can generalize Gauss method as follows. Okay, look at here. Okay, we can sum up it in this equation, right? This, diba? We says that n, because we do not know sometimes, no. In that case, that is 1 up to 100. But what if that is 9? What up to 90? So we just try to like use 90 here, and this could be 90 here. Okay, but we just used n just in case to substitute na lang. So 90 minus 90 plus 1, hold on, 90, that's in here. So 90 minus 1, that is 89. And then also here, 90 minus 2, that is 88, and so on. Okay, so still it could be having like n plus 1, 90 plus 1, that is 90, 89 plus 1, still 90, isn't it? No, that's 90 plus 1, still 91, 91, 91, 91, 91, and so on. So it goes like this na, no? N times n plus 1, and then you have 2s. What is n? N is the number of terms. 90 times n plus 1. I hope you get the idea. And suddenly it turns out like this, eventually. Okay, let us first learn the terminologies in here. You have the first term is a sub 1. Okay, take note. A sub n at term. N is equal to the number of terms, sum of n terms. You're going to add them all, and D is the common difference. And take note of these formulas. You have this and this. This one is used to find the nth term, while this one is used to find the sum. Now if you're going to add all of them, we'll have example later on. Okay, how do we have this sum formula? The same with the Gauss method. Try to look at it again. A sub n is equal to n over 2 times a sub 1 plus a sub n. Doesn't it look like this? Okay, it look like this, right? Has 1/2 times n plus 1. That is how we derive this equation. That's it. Okay, let us have the example right away. So find the 14th term of the arithmetic sequence. 14th. So there are 14 terms, 14 kabuok. You have, but you are only given 4, 7, 10, 13. And how are you going to find ang ika-14? No, this is first, second, third. Ang ika-14 atong pangitaon, what is the value of 14? So to do that, kindly memorize this equation. You have a sub n is equal to a sub 1 plus the value of n minus 1 times d. What is a sub n again? That is the term that we are looking for. This one here, the question mark. Okay, is equal to a sub 1, the first term. N is the number of terms, pila kabuok, so 14 kabuok, right? Same rin siya, 14 here, 14, n, 14, 14. D is the common difference. What is the common difference? 7 minus 4, 3. 10 minus 7, that is 3. So the common difference is 3. Very simple. a sub 14. Okay, did we got it right? Okay, a 14, we are looking for a 14 term here. 4 is the first term, 14 is the term. Okay, pila ka buok number of terms, and distance is, distance, the difference is 3. How did we get 3? 7 minus 4, 3. 10 minus 7, 3. So you multiply 14 minus 3, that is 13. 13 times 3, that is 39. 39 plus 4, that is 42. Therefore, this one here is 43. See, the work is now very easy with the arithmetic sequence. But if you're going to do it manually, like, we can take up a lot of time. 13 plus 3, 16 plus 3, and so on. But if you have this equation, kindly memorize, things get easier. Okay, another example. Find a 16. Therefore, there are 16 terms from 1 to 16. Okay, over there. There are 16 terms. And the first term is 1.5. So 1.5 is the first term. 1 point, I don't know what's happening with the pen. Okay, let us just type it in here. You have 1.5 as the first term. Okay, again, 1, 2, up to how many terms? 16 term. Over here is almost 16. It's a little bit loading. 6 terms. Okay, okay, so the end term is 16. We do not know the sum, but we are not looking for the sum, by the way, anyway. So 0.5 is the common difference. How did we solve for the we have the different given. So given the equation, a sub n is equal to a sub 1 plus the value of n minus 1 times d, you just simply substitute. So you have like 0.5 is the difference given na siya. N is 16. 16 man kabuok, so 16. We are looking for a 16. Diba? Here, 16. This, we started with 1.5. 1.5 is here. 1.5. Okay. 2. Okay. That is continuous. Up to 16. So we're looking for this term here. Okay. So you have 16 minus 1, 15. 15 times 0.5, that is 7.5 plus 1.5. Therefore, the 16th term is simply 9. So it is 9 here. Okay, very good. That's it. How about, let us have the problem solving. Kindly read. The table shows typical costs for a construction company to rent a crane for 1, 2, 3, or 4 months. These are the data. There are 4 months, like 1, 2, 3, 4, 4 months. Using that arithmetic sequence, how much would it cost to rent the crane for 12 months? So we continue up to 12 months. 12 months. So that must be a big thing. How much would it cost to rent the crane for 12 months? Pila mabayaran? Okay, so let us compute. What is the first term? Of course, that is 75,000. What is the nth term? We're looking for the 12th term. Number of terms? 12, kabuok, like this, 12. Are we looking for the sum? Are we looking for the sum? Yes, we are looking for the sum later. Okay, so with this, the common difference is 15,000. How were we able to do this? We just subtracted 90 minus 75, 15,000. 105 minus 90, 15,000. So you have here, again, the formula. You can substitute here. We're looking for the 12th term, okay? So you have here, the first term is 75,000, this one, okay? No. This one. You have the number of terms 12, common difference is 15. 12 minus 1, that is 11. 11 times 15,000, that is 165,000, plus this, that is $240,000. That is the cost that they will be paying for rent after 12 months. That's it. Okay, another example. This is just like trying to find the missing values. Sometimes the difference is the missing value or the n or what. But in this case, the missing term, okay, in the arithmetic sequence 4, 7, 10, 13, and so on, which term has a value of 301? Oh, we are looking for the n, right? Okay, so 301 is the nth term. We do not know, no? That is, we started with 4 and we are looking for somewhere here, okay, somewhere here. What okay ba? Pero we know that this term is 301, but we do not know what is the ranking from first to what? From first to what? From first to what? Okay, so we are looking for n, the number of terms, from 4 to 301. So, okay, so we have a over n already, which is this. That is n. A sub 1 is 4. We started with 4. Common difference is 3. How? 7 minus 4, 3. Yeah. That is, okay. How was it done? N, you distribute 3 times n, 3n. 3 times negative 1, negative 3. You subtract 4 minus 3, that is 1. So that is now 1 plus 3n, or, yeah, you transpose this becomes 301 minus 1, it becomes 300. So leaving you with this, and still you can divide it by 3, so that we are only left with n on both sides, 3. So 300 divided by 3, that is 100. So that's it. So 301 is the 100th term. Yeah, that's the 100th term. I hope you get it. Another example. This video is getting long. It's 37 minutes. Okay. So you're going to find the value of n again, given the first term and the common difference. The same thing. Use the equation. Substitute. Okay, and you have n is equal to 27. The same example as earlier. Okay, how about the first term? We are going to look at the first term. Find the first term. The same. You're just going to identify the first term is none. Wala takibaw. Okay, but we are looking for it. Okay, that is the question mark. The a sub n is the 15th term. So we started from question mark to up to 38, but we know 38 is at the 15th term. 15, okay, 15th term. This is the first term. We are looking for the first term. What could be the first term? This one. Okay, so n is 15. There are 15 terms. A sub n, we are not looking for it. That's not included. D is negative 3. Why is it negative 3? Okay, so it's given. Because it's given. Okay, so substitute. Okay, a sub n is 38 already. A sub 1, we do not know. We are looking for it. N is 15. Difference is 3. Negative 3 times 15. Just substitute. Hold on. 15 minus 4, that is 14. 40 times negative 3, that is negative 42. And transpose that becomes 42 plus 38, that is 80. Therefore, we started with 80. Yeah, it makes sense because it is decreasing because the difference is negative 3. 80 minus 3 minus 3 minus 3 up to 38. Okay, that's good. Can you take a screenshot? Okay, another. You have D. If A sub 1, okay, you are going to find the common difference na pod. You are given, it's a matter of mathematical manipulations. I know you are really good at it already. Are you? Aren't you? Okay, so you have, yeah, of course you are. Of course. Let us, sige be. A sub 1 is negative 6. Where is the laser? Oh, it's in here. A sub 1 is just given. 8 to 9 is 20, so like that. Just substitute that. So again, A sub n is 20, and we know that 20 is the 29th term, that is n. Okay? Please see the difference between A sub n and n, okay? A sub 1, we started with negative 6, and we are looking for a difference. So that's 29 minus 1, that is 28. 28 times d, that is 28d. How? Okay, so negative 6 transposed to the other side, that becomes 20 plus 6, that equals 26. 28. So divided by 28, that is now 13/14. 28 divided by 28, that is remaining at d. 26 divided by 28, right? So probably they are divided by 2. 26 divided by 2, 13. 28 divided by 2, 14. Simplified version. So that is the difference now. 13 over 14, or 13/14. Write an equation for the nth term of the arithmetic sequence 8, 17, 30, 26, and 35. Okay. Write an equation for the nth term of arithmetic sequence 8. Okay. We're going to write the equation this time. Okay. In the first part of the video, we're given the equation, and then we were tasked to find the terms. This time we are going to do the otherwise. Okay, the other thing. Okay, the reverse thing. So you have first term is 8, common difference 9, 17 minus 8, 9. 26 minus 17, 9. We use this thing. So you have, okay, just substitute. The first term is 8. You have this. Common difference is 9. N minus 1. Multiply. 9 times n, 9n. And this, negative 9. 8 minus 9, negative 1. And that's it. Make sure to leave n. Do not touch the n, because, as you know, this is the domain. Okay? In which you can substitute the domain to have the terms. No? Example, 17 is the second term, so we substitute 2. 9 times 2, 18, minus 1, 17. Okay, please leave the n alone. Okay, another, we have the so-called arithmetic mean, the terms between any two non-consecutive terms of an arithmetic sequence. Arithmetic mean. This is not statistics, but yeah, we are like n. The terms between, tunga lang siya sa 30 and 74. In this case, if you are going to ask, what is the center of, or what are the values between 4 and negative 4 and 5? How to do that? You have the first term, you have the last term, and you have the number of terms, which are 4, right? 1, 2, 3, 4. So, ayan. Do you have the common difference? You do not know it? You must find the common difference first to do that. Just, excuse me, just substitute. You have, yeah, this, and this, and this, and this. I know you know how to do it. That is 3. Once you find the common difference, you can now continue. 4, negative 4 plus 3, that is negative 1. Plus 3, 2. So the arithmetic means are negative 1 and 2. Okay. How about 21 and 45? Again, the first step is to know the number of terms. Pila ka buok? Diba 3 ang tunga? So 1, 2, 3, 4, 5. So 5 ka buok ang n. The first term, A1, is 21. And the A sub n is 45. As long as you know how to locate the terms, no, then you know how to do it. The next step is find the difference. Just substitute it, substitute, manipulate, and the value of D is 6. So 21 plus 6, that is 27. 27 plus 6, 33, plus 6, 39. So the three arithmetic means are 27, 33, and 39. How about the arithmetic series? 46. Okay. Example. Arithmetic sequence is like this. It is just a list. Take note. While the arithmetic series is the sum. You're going to sum it up. Take note. Series, i-add. Sequence, pagkasunod-sunod. Or just a list. Series, i-add. Okay. Let's continue. Let us recall first term, nth term, number of terms, sum of n terms. We kept on using this earlier, but now we will be using this. And again, take note of the equations. We were able to derive this sum because of Gauss method. Okay, just such a big help, Gauss. And this is the one that we kept on using. Try to memorize. No? You need to memorize this. This is very helpful. This might come out in the board exam. No? Okay. Finite, or finite no, means we know when to end. Okay. Okay, sige, let us have this example. Find the sum of the first 63 terms of the arithmetic sequence. Where's the laser? Okay. There are 63 terms. This is A sub 1. The common difference is negative 13 minus 9. That is positive, I don't know. Yeah, positive 6, correct. So again, first term is negative 19. We are looking for A sub n. We do not know what is the value of the 63rd term. The number of terms is 63. The sum of terms, we do not know. We are looking for that common difference. So since we are looking for the sum, then we are going to use this equation. But since the equation, let us try to use it. Okay, we only have the n, we only have the first term, okay, but we do not know the A sub n. Diba ang A sub n is this. We can use the formula again, this. Okay, we're going to look for A sub n. Again, A sub n is the 63rd term, no? 63rd term, this one here, okay? 63rd term. 63rd, kinaiwitan. So how to do it? We have the first term, negative 19. We have number of terms, 63. We have the common difference, 6. So we can solve for it, and that is 353. You know how to solve it? PEMDAS, okay? 353. So that is, we can substitute it now here in the equation. So that is now, okay, 353. So you are going to have 353 plus negative 19, okay, and then multiply it by 63, okay, and the answer of that is going to be divided by 1500. That is 10,521. So let us do this step by step. 353 plus, what should I say, minus 19, that is 334. 334 times 63, that is 21,042. Divide it by 2, that is 10,521. So the sum of terms from negative 19 plus negative 13 plus negative 7 plus and so on is 10,521. Ang sum na ni siya. I-add tanan. Okay? Another example, let us just try to make this quick. Find the first three terms for an arithmetic series. First three terms. Given the first term, given the number of terms, 105, kabuok. Let's copy into the mouse. Nth term, and so on, the sum. So we are going to look for the first term. But we need to also find the second and third term, right? So with that, we know that there are 105 terms. Okay, so let us do this step by step. First step. Okay, we are looking for the n. We do not know the n, by the way. No, we're talking about sa n or pila ka buok, right? But we know na ang last is 105. But we do not know the term. Pila ang last term. So how to do this? Do we have the difference? We do not have the difference. But we are looking for the first term. So how to do that? We need to find the n first. So with that, let us use these two equations are helping one another. Kani usan nitin tabang ra na siya ni. So you have n over 2. We know that a sub 1 is 9, a sub n is 105, and the sum is 741 given this. So take note in the quizzes, it is up to you how to use these two. No? Lipat-lipat na siya gamay. 105 plus 9, that is 114. Okay. 114 times n, that is 114n divided by 2. 114 divided by 2, that is 57n. Okay. And divided by 57. 57 divided by 57, that is 1, or n. 741 divided by 57, that is 13. Okay. Therefore, the n is 13, and we can now substitute it in the original equation. Okay, that's it. Hold on. Therefore, the difference is 8. Let me erase the ink. Okay, so that you can see the process. And we can now follow. We have first term 9, the second term 9 plus 8, that is 17. 17 plus 8, 25. That's it. It's a really long discussion. Okay, it's almost an hour. So let us find the first three terms for an arithmetic series in which a sub 1 is equal to 9, and a sub n is equal to 105, s sub n is equal to 741. I hope this is... I'm sorry. So let us have another word problem. A radio station considered giving away $4,000 every day in a month of August. Suppose that August is composed of 31 days, right? January, February, March. But do you use your basta leap year mo sab no? August 31 days for now. For a total of 124,000. So here. Giving away 4,000 every day. Hatag sila 4,000 every day. For 31 days. August within the month. For a total of 124,000 at the end. Instead, they decided to increase the amount given away every day, while still giving away the same total amount. If they want to increase the amount by 100 pesos each day, so this must be the difference, right? How should they give away the first day? Oh, we are looking for the a sub 1. A sub 1. We are looking for this. Let us try to see. This one, they are going to, this should be, hold on, 124,000. This should be the a sub n, right? At the end, man. A total of, I know, a total of, that means s sub n. Let us see here. Yeah, correct. And 31 days is the end. No, month of August. 31 is the end. And we do not know the first term, but we do know that it starts, what's this, 40,000? Ah, yeah, they're going to give 4,000 every day. So with that, let us use this equation to find the value of the a sub n. We do not know the value of a sub n, and we are looking for a sub 1 primarily, no? So primarily, we're going to use this equation, kind of good, but we do not know the value of a sub, no, we do not know the value of a sub n, yes, but we are looking for the a sub 1, money ang question mark. Yan. So the a sub n, for us to know, let us use the other equation. We have a sub 1, a sub n. We substituted because there are 31 days here too. So you have a sub n is equal to a sub 1. Okay, hold on. So you have, ayan. So we are looking for this. We do not know this. We do not know a sub 1. Okay, but we can, yeah, diba? A sub n is equal to a sub 1 plus 300 now. So since we have a sub n, you have a sub 1 plus 300 na, no, with this type of manipulation. So we can now substitute a sub n to the original equation, which is this. It will sum up like, let me move it. Look at here. Diba, we use this primarily, ano? Primarily this equation. So you have, I hope you can follow, no? So you have, we stop in here because we do not know the value of a sub n. But now when we go to another value, another equation, we found out that a sub n is equal to a sub 1. So a sub n is now a sub 1 plus 300. So to manipulate it, a sub 1 plus a sub 1 is 2a sub 1. So you have, yeah, cross multiply, oh no, you have to like distribute, right? So you have 31 times 2a sub 1 over 2, that is 62, divided by 2, still 31 a sub 1. So 31 times 300,000, hold on, 31 times 3,000, that is 93,000, divided by 2, that because it has 2 here, that is 46,400. Manipulate a little bit, transpose to the other side, that becomes minus 465, that is now 77,500. Divide it by 31, so that we are only left with a sub 1. So 77,500 divided by 31, that is 2,500. So they should start giving 2,500 at the start of the day. That makes sense because 2,500 plus 100 plus 100 plus 100 up to 31 days, if you're going to count, that is summing up to 124,000. Sounds um, a little bit tedious. Okay, how about the sigma notation? This is the last one. Okay, used to express a series or its sum in abbreviated form. So you have, yeah, in abbreviated form. I don't know if you are familiar with this already, but in our statistics class next semester we are going to use sigma notation, and this sigma symbol is a Greek alphabet for letter C, which means letter S, which means sum. Okay, let sum. As you can see, there are parts of the sigma notation. First is the sigma, okay, which symbolizes sum. We're going to add all those that are in the equation in the series. Lower limit. Take note. This is 1. Example, this is 1. This is 5. These are the number of terms. First term or the domain. Okay, 1 up to 5. Domain 1, 2, 3, 4, 5. You're going to substitute 1 to the equation, which is this. Okay. Example, you have a sub n. So you're going to substitute 1 here, 2, 3, 4, 5, because the upper limit is only 5. So you're going to stop at 5. Anyway, we're going to have example later. Here. So again, you have the equation here. This is the function j plus 2. So you start 1 plus 2, that is 3. Another 2 plus 2, 3 plus 2, 4 plus 2. Why did we stop at 4? Because the upper limit is only up to 4. So again, you start with the domain 1, 2, 3, 4, up to 4 only, because this. Okay, I hope you got the idea. How about this? You start with 4, so that must be 2 times 4, 8, 4, 5, 6, 7. We stopped only up to 7. Okay, again, you have lower limit, upper limit, equation. Very simple. Then you're going to add them all. 2 times 4, 8, plus 10, plus 12, plus 14, that is 44. In the sequence, if the sequence is arithmetic, you can use the S sub n formula. Yeah, if it is arithmetic. Hold on here, okay, to make it quick, because sometimes, how about if it is up to 1000, 4 up to 1000, so that is going to be a long thing. So we can use the S sub n formula. What is the S sub n formula again? Equals 1/2 times 1/2. Okay, like this, or n over 2 times a sub 1 plus a sub n. Okay, so how to do it? Okay, in case so you started with 1, so the first term should be 1 plus 2, that is 3, the first term, and then the last term, this is the technique, the last term is 4, so 4 plus 2, that is 6. Therefore, okay, you must also know the interval, 4 to 1, there are 4 kabok. How about 1000 to 4? That is 996. No, that is for n. We're looking for the sum, right? The difference we do not know. But with that, I think it does not matter. So let us use this. N over 2. N is pila kabuok? 4. How to find the n gani? Again, 1 to 4. Upat kabuok. Kani daw? 4 to 1000. Interval nila. Dili siya i-subtract, but kung ano nila, we may subtract pero plusan of 1. So you have 4 over 2. A sub 1 is 3. Last term is 6. Therefore, the sum is 18. is the sequence arithmetic 10, 17, 26, 37. Try to see. What is the difference? No, because the common difference is not constant, diba? 7 dire, 26 minus 7, that is, may mo na siyang 9. Diba dili siya? Okay. Okay, another factorial, no? Just those another examples. How about this is the last slide, I swear. Okay, this is the rewrite using sigma notation. Sigma, diba balino, no? You're going to write sigma notation. You are given the first term, diba? First term. You have the last term, right? The last term. How many terms? Upat ka buok. Upat ka buok. There are 4 terms. What is the common difference? 6 minus 3, that is 3, right? Ay, lalala. Okay, that is 3. So let us define it here. And arithmetic, okay, D. Okay, you have that. So you have, you just use this equation, okay? And again, do not forget ang n atong ipabilin, okay? Ipabilin na to ang n. Because that is where we can input something, no? Substitute something. So, yan. A sub 1 is 3. The difference is 12. So, yeah. 3 times n, 3n. Ayan. Okay nga naman eh. No? 3 times n, 3n. 3 times negative 1, negative 3. So, negative 3 plus 3, cancel na siya. Nahabili na lang 3n. So, this is now the formula nga ato ibutang diri sa kaninga side, sa right side. And nganong 1 man eh, because we started with the first term, 1 up to 4th term, upat ka buok. Okay, let us see, let us check be. Example 9. Ang 9 is 3. 3 times 3, 9. Very simple. Okay, so that's it for our lesson in series and sequence. It took us an hour to discuss it, but I hope you were able to listen carefully. You may go back to the video, okay, so that you can learn it again. Okay, I will be uploading the activities and quizzes, so hopefully you can answer all of those. Thank you so much, and see you.